So practice test, describe the math pattern of the sequence, 100, 60, 36, and find the next three terms. This is a geometric sequence, and R is 60 over 100, or 0.6, or, yeah, I use 0.6 is what I used for this one. And then it says to find the next three terms. 0.6 times 36 gives you, 21.6, and then 12.96, and then 7.776, or you could get R equals 3/5 and do it as a fraction, and you get 108 over 5, 324 over 25, or 972 over 125. If you did it as a fraction rather than as a decimal, I have both answers here. Number 2, easier, is arithmetic. D equals -9. You're going down by 9 each time. So the next three numbers are 24, 15, and 6.
If it's like minus or plus, right?
Right. Arithmetic is you're adding or subtracting. Geometric, you're multiplying. Technically, for arithmetic, you're adding, but like in this case, I'm adding a negative.
Yeah.
Okay. Geometric, I am multiplying. I am multiplying by a number less than 1, so it's going down. Okay. If it changes sign every other term, that's a dead giveaway. It's not arithmetic, it's geometric. Okay. If it's every other term, if it changes sign in the middle of the sequence, then it's going to be arithmetic is what it's going to be. Next one, state of each series, either arithmetic or geometric, state the value of the common difference or ratio, either D or R. That's what this is. What's your D? What's your R? Looking at this one, this is in linear form, so it's arithmetic. And D is what I multiply times N. Okay, and it's a D in this case. A D, not a D. Okay. This one, because I have an exponent, it's geometric, and it's 3 is my R. That's what I'm raising to the power is 3. So I'm increasing by multiplying by 3 each time. Arithmetic sequences, find the 120th term. So what do I need to do to find that? I need the first term, a sub 1, which is -15. I need to find D, or my difference, -8 minus -15, or 7. And then I know N is 120, plug it into the formula. A sub 120 is -15 plus 120 minus 1 times 7. And you end up getting 818. Next one, write out the first 4 terms of the sequence. The most common error that students make is not listing the first term. Your first term is -8. Your first term is not -3. -3 is the second term. It's a recursive formula. Say it writes the first 4 terms. That is the first term. It is an extremely common error to not give me the correct first term in the answer. And yes, I will mark you wrong for that. And a sub 3, add 5 to that, I get 2. A sub 4 is 7. Okay. Watch that. Pay close attention to what it's asking for. It says the first 4 terms, and since this is the first term, rewrite it. Yes, you are supposed to just rewrite what I already gave you as part of your answer. That happens. On the AP test, that is a very common get a point by rewriting one of the statements that are given in your work. It's odd, but hey, it's that important you rewrite it. Okay? So number 6, find a sub 14 in the arithmetic sequence. Okay? Where a sub 2 is 4 and a sub 8 is 5.8. This is one where you figure out what D is and then just add it so many times. So what we have is we have the second term, 4, third, 4th, 5th, 6th, 7th, and then the 8th term, 5.8, and then 9, 10, 11, 12, 13, 14, and that's what we're looking for. Okay, there's a couple of ways to do this. First thing is you need D. You need to know what D is. Okay? To find D, take the term we have, 5.8, minus the term we have in front of it, 4, and divide it by, in this case, 1, 2, 3, 4, 5, 6. Place. And you get 0.3. No, you divide by 1 more. Because how do I get from here to there? I have to add D 1, 2, 3, 4, 5, 6 times to get from 4 to 5.8. And you get 0.3. Okay. Now, there are a couple of ways to get to the end from here. I can add 0.3 several times to get to this. Okay, I can do that. Let's say it's farther down the line, and doing that several times doesn't work real good. Well, here's the thing. This is a sub 2. 1 in front of that is a sub 1. So if I subtract 1, I get, or subtract 0.3, I get 3.7. A sub 1 is 3.7. Now I have my first term, I have D, I have how many terms? I can plug it in the formula. A sub 14 is the first term, plus 14 minus 1 times 0.3, and the 14th term is 7.6. If I add 0.3 repeatedly to get to the 14th term, I'll get it the same way. Either way will work. Find the 2 arithmetic means. We need to find D and just add D a couple of times to fill in the blanks. Take the last term, negative 50, subtract the first term, negative 8, divide by 1 more than we have spaces because I have to add D 1, 2, 3 times, so I divide by 3. And you end up getting D is negative 14. So negative 14 plus negative 8 gives you negative 22. And then add negative 14 to that, you get negative 36. And those are your 2 numbers. Okay. Okay, next one, geometric sequences. Find the 10th term, state your answer in simplified fraction form. So the first thing I need to do is I need to find what R is. Take in any one of the numbers, negative 9, divide it by a number in front, reduce, you get negative 1/3. Or I can say, ooh, negative 1 times negative 1/3 gives me 1/3. That's an easy one to figure out R from the sequence itself. So I know R, I know A sub 1. My formula is the nth term, in this case the 10th, A sub 10 is a sub 1, 27, times r, negative 1/3, to the 10 minus 1 power, n minus 1. And you work that out, and you get negative 1 over 729. So for this one, question number 9, it gives you a hint. Write out the first 4 terms. The first term occurs at n equals 1. A sub 1 is 5 times negative 3 to the 1 minus 1 power. 1 minus 1 is 0. Negative 3 to the 0 is 1. So my first term is 5. Then I can plug in 2 and plug in 3, plug in 4, and simplify it down. Or I could go, oh, what's my r? My r is negative 3. Multiply that times negative 3. So my second term is negative 15. My third term, negative 15 times 3 is positive 45. And my fourth term is negative 45 times 3, which is negative 135. Or you could plug it into the powers in your calculator and do it that way. Okay. First 4 terms. Find a sub 9 in the geometric sequence, where you're given the first and the fourth. This is the same idea we did before. The easiest way to do this is to figure out r. Okay. So I take the last one, divide it by the one in front. And in this case, because I'm going from the third, a sub 3, negative 500, 4, 5, the sixth term is 4. So that means I take the cube root of that. And you end up getting negative 1/5 for your r. What? Sorry, thank you. Should be 1/5, not 1/4. My bad. You end up getting negative 1/5. Thank you for teaching that. And then you have a couple of choices. You're going for the 9th sequence. Here's what I would do. See, this is the 6th, 7th, 8th. We want to figure out what that is. Easiest way, negative 1/5 times 4, negative 1/5 times that, negative 1/5 times that. That's the easiest way to do this. It's not like arithmetic where I might ask 20 places out, which would be a real pain in the butt. I'm only going to ask 2 or 3 places beyond that. I'm not going to ask for anything much larger because with geometric sequences, it's too hard to work with numbers that large for your exponents.
How do you put that in calculator? Right. 4 over negative 500.
Put that in your calculator as a fraction, it will reduce, and then take the cube root of that answer. That would be what I would do, because it will automatically, you type in a fraction, your calculator will reduce it down.
Okay.
And give you a reduced fraction. And then it's 1 over, so take the cube root of the denominator, it's 1 over the cube root of the denominator. And you do that, you multiply it out, and a sub 9 is negative 4 over 125. Okay. Find the 3 geometric means to the sequence, fill in the blanks. So I have 1, 2, 3, 4 to get through there. So r is the 4th root of the last one, negative 32 over 27 divided by negative 6. And you get r is 2/3. What that reduces down to. And multiply 6 times 2/3, multiply that times 2/3, multiply that times 2/3, and you get negative 4, negative 8/3, and negative 16 thirds. Question? Okay, find the sum of the series. Sum formula for arithmetic series. The number of terms divided by 2 times the first term plus the last term. So I need to have the number of terms that we're adding together. Remember, it's the top minus the bottom plus 1. Because we start with 1, it is that. So n is 91. My first term, plug in 1 for 2. Or plug in 1 for n. So I get 20 for my first term. My 91st term, plug in 91. 2 times 91 is, you end up getting 200. Okay. So the sum of the first 91 terms is 91 over 2 times 20 plus 200. Yes. Put in 1. Put in 1 for n. Let n equal 1. 2 plus 18. Great. And you get 10,000 and 10. 1, 0, 0, 1, 0. Find the sum of the series. Well, I know the first term. I know the last term. What I don't know is how many terms. I need to know how many terms. So we go back to our original arithmetic sequence formula, plug in the things we know to find the things we don't. The last term is 148. My first term is 10. N minus 1 times D. How do I get from 10 to 16? I add 6, so it's times 6. Distribute, solve, and you get n is 24. So there are 24 terms in the sequence. So I have the first one, I have the last one, I have how many there are. So the sum of the first 24 terms is 24 over 2 times 10 plus 148, and you get 2,496. All a matter of knowing which formula to use when. That's it. Which formula to use at what point. That's what this is all about. Which one do you use when? It said the formulas will be there, but you have to know which ones to use at the right time. That's on you. Geometric series. And there's a hint. Geometric series, which means it's going to be R, not D. So you can eliminate any of the ones with D in it. Okay. So, I know my first term. I know how many terms, because it tells me 8 of them. And then I need to figure out what R is. How do I get from 15 to 16? R is negative 60 divided by 15, or negative 4. So the sum of the first 8 terms is the first term times 1 minus R to the 8th power, not 8 minus 1, watch that, over 1 minus negative 4. And you get negative 196,605. Next one, same idea, same formula. You need to know the first term. You need to know what R is. And you know how many there are. There's 9 terms, because I'm going from 1 to 9. So n is 9. A sub 1, go ahead and put 1 in for n. Get 1 for n, that's 2 times 3. So my first term is 6 in this case. And r is what I'm raising the power, so r is 2. Because it's 2 to the nth power, whatever I'm raising to the nth power. Plug into the formula. Sum of the first 9 is the first term times 1 minus r to the 9th power all over 1 minus r. And 3066. Question? Okay, performance task. You bought a plot of land on a hillside for a Christmas tree farm. You analyze the dimensions of the available land and you determine you will be able to plant 60 trees at the base of the hillside, the first row. There will be a total of 25 rows of trees. You calculate that for each row, you will be able to increase the trees by 4. Given this information, answer the following questions. Is this design best modeled using arithmetic or geometric? How many am I increasing by? 4. Am I adding or multiplying by 4? Am I going to have 29 rows in the 20 trees in the second row, or 100 trees in the second row? I'm going to have 29. So this is arithmetic because I'm adding. Okay. Write the explicit equation you can use to calculate any number of trees. This means write the equation in the form a sub n equals. Fully simplify your final equation. So we're using the formula for the nth term, plugging in the first term and d and simplifying. So our first term, there are how many trees in the first row? 26 trees. So actually it'll be 60 trees. I misread that when I was doing 60 trees in the first row. How much do they go up by each time? 4. So d is 4. That's my first term, a sub 1. That's my d. So a sub n equals the first row plus n minus 1 times d. Distribute to 4. A sub n, 60 plus 4n minus 4. Combine up like terms. A sub n is equal to 56. Sorry, should rewrite this formally. 4n plus 56. How many trees will be in the middle row, i.e. the 13th or a sub 13? A sub 13, use the one we just did. 4 times 13 plus 56. And you get 108. Middle row is going to have 108 trees. Start with 60 in the first, go from there. How many trees will be in the last row? Or a sub 25. A sub 25 equals 4 times 25 plus 56. 4 times 25 is 100 plus 56. 156 trees in the last row. How many total in there? Or S sub 25? And if you read the problem, ooh, S sub 25, ooh, I'm either going to use this one or I'm going to use this one. We're talking arithmetic. I'm going to use this one. This one has R in it. R is not what I'm dealing with. I'm dealing with D. I go with this one. So the sum of the first 25 is 25 divided by 2 over the number in the first row, which is 60, plus the number in the last row, 156. And so you get a total of 2,700 trees. Key is knowing the formulas and which ones to use when. The formulas are going to be on the board, but you better know which ones are used when. Okay. When you're taking the test, I want to see the formulas filled in and used.